Good evening. We'll wait for 5 more minutes to let others join and then we'll start our session. Good evening, everyone. I'll just share my screen. I hope you all can hear me. Are you able to see the slideshow?
Yes, ma'am.
Yeah, thank you. So, welcome to the last session uh, in this course for NPTEL online course, that is Drug Delivery Principles and Engineering. So today we'll just be talking about the numericals because we have covered most of the questions and most of the content in the past 12 sessions. Yeah, so let's start with some of the numericals which were there in the assignments and which would be a good practice for you guys to know that this is the type of questions, type of numericals which you can expect in your last exam. Sorry, sorry, I have to keep on switching between these two windows. So yeah, the first one, I hope you can see the question. I'll just read it out for you. Yeah, so there's a drug that has a half-life of 30 minutes in its native form, and we have conjugated PEG to the drug to improve its pharmacokinetics, and the modified drug is then injected intravenously with an initial plasma concentration of 1 mg per ml. And after 12 hours, the concentration of the drug in serum is 0.5 mg per ml. So now we have to calculate the change in the half-life of the drug after modifying, assuming that first order kinetics of elimination is followed. So if you guys have understood the question, you can give it a try. I can wait for a few minutes, see if you're able to solve it. If not, then we'll also discuss the answer as well as the steps we have done to arrive at that answer. Yeah, so pretty simple question. We have a drug which has a half-life of 30 minutes. Then we have modified it by conjugating PEG, and now we want to calculate what is the new half-life, and then we have to report what is the difference in between these two half-lives. Is the question clear? Does anybody have doubt in the question itself? I'll wait for a few minutes and then we can discuss the answer. If anybody has already solved it, then you can volunteer to let me know the answer as well. Anybody is able to solve this, or shall I discuss the answer? Okay, so we'll look at what the answer is. So this is just the formula that needs to be followed for first order kinetics. So this is your answer. So whenever you have numericals in the exam, in the final exam as well, you will always have a range given for your numericals. So your answer can fall anywhere between 11.2 to 11.9. So if you have got the answer in between these two in these two values, then your answer is correct. So let's look at the method to solve it. So this is one, there are two methods to solve this question. This is, I've taken the longer method because if the values change, then you would be able to solve the question even if different values are given with the same method. Okay, so let's first see what all things we have. We have the initial drug plasma concentration. So if you follow this formula here, it says Ct is equal to C naught e raised to minus Kt. So your Ct is the final drug concentration, C naught is the initial drug concentration. So we have both of these values. And then so we have been asked that you've been given one case first of all, that you have this initial drug plasma concentration and the final is this, and the time for this is 12 hours. So we first need to calculate this K elimination constant. So for that, what you do is you just use this formula. You have all the values here. You have Ct, you have C naught, and you have T as well. This is your 12 hours, which is already mentioned here. So if you solve this, you will get some value for K. Now what they have asked is for half-life, the half-life that has been changed. What you can do, you can use the same formula. In that case, your final concentration is just going to be half of your initial concentration. So now if you put the value for K that you have got again in this formula, you will get the answer as 12. So initially the half-life was 0.5 hours. Make sure that you see all the units. So this says 30 minutes. So that means it's 0.5 hours, and the new one that we have got is 12 hours. So the difference, the change in half-life will be 11.5 hours. So our answer falls in between these two values. So is this clear? So this is the longer method to get the answer for this question. I'll also tell you the shortest method. So if you read the question carefully, you have been given initial plasma concentration as 1 mg per ml and the final concentration as 0.5 mg per ml. If you look at these two values, you'll see that the final concentration is already half of the initial concentration. It means this 12 hours is nothing but the half-life of that particular formulation. So they have already given you the new half-life, what half-life will be there after modification. So if you're just careful in reading the question, you'll instantly get the answer. So your new half-life now is 12 hours. You just say that the new one is 12 hours and the old one was 0.5. So you'll anyways get the answer as 11.5. Is this clear? Both the ways of approaching at this question? If there are any doubts, or if the explanation is not clear, you can ask me again. I'll go over the question once more. If not, then I'll just go ahead with the next question. Is this okay? Okay, I'll move on towards the next question then. Everybody can hear me, right? Okay, somebody wants it once more. Okay. At the end also I'll again go over all the questions, but right now I'll just repeat this. So the question is, a drug has a half-life of 30 minutes in its native form. Then PEG is conjugated to this drug to improve its pharmacokinetics, and the modified drug is then injected intravenously, and the initial concentration of this drug is 1 mg per ml. After 12 hours, we see that the drug concentration in serum is 0.5 mg per ml. Now we have to calculate what is the change in the half-life after this modification has been done. So the initial half-life was 30 minutes, then it is modified. Now we need to find out what is the half-life of the modified drug. So for that, what you can do is, you have all these values. You have the initial concentration, you have the final concentration, and you also have the time given. So what you can do, you use this formula because the question says that it is first order kinetics. So you need to remember these formula. You won't be given these formula in the final exam. So you take this formula, you put all the values, you will get the elimination constant, this the k elimination constant. Now you take that value and then you put it again in the formula, where now you know that we have to calculate the half-life. So your CT is, that is the final concentration of the drug, is going to be half of your initial concentration. So you need not know what is the initial concentration. If you just put it in the formula, it gets cancelled out. All the only variable that you don't know the value of is your T half. So if you then calculate, you'll get 12 hours, and then your new half-life is 12 hours. Your original half-life of the drug was 0.5. If you take the difference, you'll get 11.5. Is this okay? Who asked me the question? Yeah, just let me know if it's clear. So there's another way of approaching this question as well. If you read the question, the initial half-life was, the initial concentration of the drug was 1 mg per ml, and the final concentration is 0.5 mg per ml. So if you see, this is already half of that. So whatever value you have been given here, this 12 hours is nothing but the half-life of that new drug. So the half-life, you don't even have to go through all this method. This I've just given you an example. If there are different values here, then you'll still be able to solve this question. So if you see, 1 mg per ml is given, 0.5 mg per ml is given. You have already been given the half-life, which is 12, the half-life of the modified drug. So if you just take the difference of the new half-life and your initial half-life, you'll still get the right answer. Is this clear now? Okay, yeah, thank you. So I'll move on towards the next question. The next is, a polymer is made of the following composition. And so we have been given what moles of the molecule, the polymer is having what weight, and we have to then calculate the polydispersity index. So I hope you people know what is polydispersity index. If you know that, then you'll know how to approach at this answer. Even if you're not calculating in this session, you can, if anybody wants to volunteer, you can just tell me the approach of how you're going to solve this, and then you can anyway solve it at your own leisure time. I'll wait for a few minutes for you to read the question. Please let me know if there are any doubts in the question itself. We can clear that and then we can go ahead with the solution.
We are supposed to use the formula MW by Mn to solve this.
Yes, so your polydispersity index is a ratio of your MW and Mn. Your MW is your weight average molecular weight, and Mn is nothing but your number average molecular weight. So polydispersity index essentially gives you the distribution of how your polymer is, whether it's monodisperse or it's polydisperse. So, sorry. Yeah, so since you know the formula right now, all you need to know is, so you have been given the number of moles in this formula is nothing but Ni, and the molecular weight of those number of moles, that is your Mi. So if you know these two formulae, it should be pretty straightforward. What you do is you first calculate the Mn, which is nothing but you just multiply your number of moles with the molecular weight divided by your total number of moles, and then you put these values again for the weight average molecular weight, which is your MW, which is the formula given here. You calculate these two values, and then you take a ratio of these two. Your MW will always be in the numerator, it's always MW by Mn, and then you get this polydispersity index. So again you'll have a range given here. Your answer could range from 0.7 to 1.3. Is this correct? Everybody got this? So the only catch here is you people need to know what is polydispersity index, how it is calculated, and the formula to calculate both number average and weight average. Shall I move on? Okay, let's look at the next question then. So the next is, a drug A is injected into a patient. The rate of elimination of A is 25 grams per minute and its plasma concentration is 5 mg per ml. What is the rate of clearance of the drug from the body in liter per minute? And we have to assume that the drug distributes in the total body water. So we have been given the rate of elimination, we have been given the plasma concentration. We just need to know what is the rate of clearance from the body. So take your time in reading the question, understanding it, and see if you can solve it. Anybody wants to volunteer? I can show you the formula that I've used to solve this. So there's a formula for clearance. So clearance is nothing but how much amount of drug is getting removed from the body at a particular rate. So the clearance is your rate of elimination divided by your plasma concentration. So with this, I think it should be pretty straightforward to solve. Still, I'll let you people try it once.
5 into 10 to
Sorry? Can you please repeat? I didn't catch your answer.
5 into 10 to the power 3.
Okay. Thanks for answering. Does anybody else have another response? We'll see, look at what the answer is. Meanwhile, somebody's asking me similar like this problem are asked in final exam, ma'am, or any other yeah, so this is like a glimpse of like I also don't know what kind of problems would be asked, but these are some of the concepts on which problems could be asked. So there are not many calculatable concepts in this particular course. Most of it was just theory. So this could be a good practice. If you know all these concepts, then you can calculate any problem that is given. So maybe in a different question you could be given these two values, and they'll ask you to calculate the plasma concentration. So most of the questions will revolve around these concepts only. I hope I'm able to answer that question. Yeah, so let's look at the answer. Yeah, so I think you were correct. How did you reach to 10 power 3? I don't think so. So just look carefully at the units first of all. It shouldn't be liter per minute. I mean, your 10 power 3 shouldn't come. Your 5 was correct. I think you must have missed some of the factors while conversion. So yeah, as I said, we have a formula which says that clearance should be rate of elimination divided by your plasma concentration. So we already have rate of elimination given, which is 25 grams per minute, and plasma concentration is 5 mg per ml. So you just take the ratio. The catch here is you need to know the conversion of the units. So please pay attention to the conversion of the units. So you either convert everything in gram or everything in milligrams. So if you do that, you should be getting an answer as 5 liter per minute. You shouldn't be getting the 10 power 3 factor. And again, your answer can range in between 4.8 to 5.2. Is this clear? So
Yes,
here,
ma'am.
yeah, here I've converted everything to mg, and I've kept liter per minute as it is because that's what the unit has been asked. So you have to just convert your grams to mg. That will be okay. Yeah. Okay, so I hope this explanation is clear. I'll anyways be uploading this particular video as well as the PPT. So if anybody is missing the explanation, you can go over these slides, and yeah, that should be clear enough. Okay, I'll move on towards the next question then. Next is, if a particle takes time t to diffuse L mm, how long will it take to diffuse 4 L mm? So we have been given a time, we have been given the length the particle diffuses into, and then we have given a new length, and we have to calculate how long will it take. So these are the only values that we have here. So if you people know the concept of diffusion, you should be able to answer this. Anyone getting at the answer or the method to solve it? Okay, let's look at the answer. The answer is 16t. So this is done using the concept of root mean square displacement. So how long will your how much distance your particle will travel is based on this formula, where root mean square displacement is your root 2 dt. So d is the diffusion coefficient, it is the property of that particular molecule, and time it takes to diffuse. So here we don't need to know the value of diffusion coefficient actually. We just have to take ratio of your so because it's the same particle, so your diffusion coefficient will not change. As I said, it's a property of that particle. No matter you wherever you put that particle, that value won't change. So it's the same particle, hence we can just take the ratio of these two lengths. So initially it is taking time t, capital T, to travel L distance. Now we have been asked how much time will it take if your distance now becomes from L to it goes to 4L. So you just take a ratio of these and you'll get the new time as 16t. So it's not like a linear relationship. If your distance was L and it is taking time t, now if you change your distance to 4L, it actually takes a pretty longer time. It goes to 16t. Is this clear? So this is actually a MCQ type of question, but this could be asked as a numerical as well, so that's why I just included it. So your numericals, I think if I'm correct, your numericals will not carry any negative marking in the final exam, so you just have to enter the value, that's all. So no negative markings for numericals. Shall I move on towards the next question? Yeah, I think you'll have negative markings if I'm correct. You'll anyways get the instruction sheet before the exam starts, so you can check in that. But as far as I remember, I think there is negative marking included for this, for the final exam. It usually is for most of the MCQ questions. For numericals, it won't be there. But still, I would recommend you go through that instruction sheet before you start answering the questions. Okay, let's look at the next question. Next is, consider that a drug A is loaded into two separate reservoirs whose drug releasing areas are in the ratio 2:1, and the loading concentration of the drugs are in the ratio 1:2. What is the ratio of mass of drug released in the same amount of time for these two reservoirs? We have to assume that the reservoirs are flat and non-erodible. The drug diffuses through a semi-permeable membrane in both cases. So what is the question? We have two different reservoirs. They have different areas and they have different loading concentration of the drug. The drug is still the same. We just have to calculate what will be the ratio of the mass of the drug, how much drug is being released from these two reservoirs in the same amount of time. So whenever a question like this comes, you first have an initial glance at the question and you first note down few things. First, in this question, the drug is still the same, so all the properties related to that drug will be same. Its partition coefficient, its diffusion coefficient, those will be same. Then it's again what is given, same amount of time, so the time is also same. The only thing that is changing is the area of that particular device and how much drug was initially loaded into that. So yeah, you can try attempting this question. I'll wait for a few minutes. Somebody is saying 1:1. Okay, so someone has already calculated it for this question. I hope it's the answer for this question only. Yeah. So we have one response as 1:1. Does anybody else have another answer or still wants to try calculating it? Thank you for answering. Okay, we'll look at the answer. Yeah, so the question is, you have to tell the ratio. So the ratio will be 1, which you are correct. So yeah, so this is how it's solved. So we have a formula for this type of device. The device here is a non-erodible reservoir, and for that, to calculate how much mass of the drug is being released, we have this particular formula where A deals with the area of the device, D is your diffusion coefficient of that particle, K is the partition coefficient, is the solubility of that drug, C naught will be the initial concentration of the drug, L is the length of the device, and T is the time in which the drug will be released. So too many values here, but we have already seen from the question that since the drug is the same, your D, K and Cs, which is the property of that drug, your diffusion coefficient, partition coefficient and solubility of that drug in the polymer, that is not going to change. That will be the same in both the cases. So the only thing that is changing is the ratio of the area of these two reservoirs and the initial concentration of the drug. So that we have been given that the ratio of the area is 2 is to 1. So your A1 is to A2. So I just have to take a ratio of these two values, which are the mass of the drug that is being released from these two devices. So your ratio of the area is 2 is to 1. Your ratio of the initial concentration of the drug is 1 is to 2. We can neglect the L here because we are assuming that the reservoirs are flat. So your L will not be, the length of that device is not being considered here. So if you just take the ratio of these two, you'll get the question, you'll get the answer as 1. So what this question is saying essentially is no matter if you change the area and the initial concentration in this particular ratio, the same amount of drug will be released in both the devices. Is this clear? Please let me know if there are any doubts in the question or in the solution, and we can go over the questions once more. If not, I'll move on towards the next question. Yeah, next is if we have to consider a microsphere of diameter 1 micron. Calculate the number of such particles that would be present in 1 mg if we have the density of the material as 1.3 gram per ml. And there are two correct answers in this. So we have to pick two. Yeah, so do let me know if you know how to solve this or if you already have the answer. Okay, Pooja is answering as option A, but again we have to choose two options. I'll consider option A as one. If you want to give me another answer, that is also okay. Thank you for answering. Anybody else? No? Okay. No more responses. Then I'll just discuss the approach. So the answer is 1.469 to 10 power 9 particles per ml. So Pooja, your one answer was correct. Another was just a conversion of these two values. So option 1 and option 3 is the correct answer. So let's look at the method a little. So we have been given diameter of the microsphere. We just have to calculate its radius. So from a micrometer I've converted it to centimeter. This I've done because so that I can have everything in the same units. And then we have been given the density, which is 1.3 gram per ml. So to know how many particles, so essentially what we have been asked to do is we have to calculate how many of these particles which have a diameter of 1 micron and a density of this would we be able to fit in 1 mg of the total amount. So first what we do is we calculate the volume of one particle. So since it's a sphere, we know sphere volume is 4 by 3 pi r cube. So you just put the value of your radius that you have got, and then you will get the so since it's centimeter, 1 centimeter cube is 1 ml, so you get the value in for the volume in ml. So this is the volume of your one particle. Now to calculate what would be the mass of one particle, we just make use of density is your mass per unit volume. So you use that formula, and then you calculate what would be the mass of one particle. So if you just put these values, you will get that so one particle of this microsphere is going to have a mass of this much, 0.68 into 10 power 9 mg. Now what the only thing now that is left to do is, I know that the entire mass of my particles is 1 mg. I just need to know how many particles I'm going to fit into this 1 mg. So what you do is you just take a ratio of these two, 1 mg and then mass of each particle, and then you will get a value of 1.47 into 10 power 9. So I've just rounded it off. The actual value would be 1.469. So 1 is 1.469 into 10 power 9. If you just shift the decimal here, you will increase the power here. So now another answer you will get as 0.1469 into 10 power 10 particles per ml. Is this making sense? Unit is actually particles per mg, because we have been asked to calculate how many particles would there be in 1 mg, but this looks like some printing mistake here. So yeah, is the method clear? Does anybody have any doubt in this solution? Shall I move on towards the next question? Okay. The next is, in a membrane reservoir system with 5 micron membrane thickness, 5 mg of drug is released after time t. If the desired release of the drug is 1 mg, what should be the thickness of the permeable membrane? We have to report the answer in micrometers. So again, so similar question where you have been given two cases. The drug is still the same, and what has changed is we have changed the dimension of this reservoir system. So if you actually we have changed how much release we are going to get. So you initially have a 5 micron membrane, 5 micron thick membrane in the reservoir system, and 5 mg of drug is released after time t. So it's asking us, if the release of the drug is 1 mg, what should be the thickness of the permeable membrane? So here, instead of calculating how much amount of drug is going to be released, we have to calculate what should be the thickness of this membrane, so that instead of 5 mg we get only 1 mg in the given time. So try calculating this and do let me know if you know the answer. So we already saw the formula for reservoir system, right? So we have to use the same one here. No response? Okay, let's look at the answer. So the answer should range from 24.8 to 25.2. I think it would come somewhere around 25. Yeah. So again, we'll first look at what we have been given. So we know the length of the thickness of the. So here L1 I am considering it as the thickness. So that is 5 micron. The amount of drug, the mass of drug that is being released is 5 mg, and we have to then calculate for a different case where mass of release should be 1 mg. In that case, what thickness should the membrane have? So we know the release kinetics from membrane reservoir system is given by this formula, where your mass is your area of the we just saw this area of the reservoir, your drug diffusion coefficient, partition coefficient of the molecule, the solubility, into your time and then divide it by the length of the device. So as I said, look at the question carefully. If it's the same drug, most of these characteristic values are going to be the same. So your DKCS will definitely be the same. Here we have not been given the area, so we assume that the area of the device is still the same. So the only parameter that is changing and that is going to govern your release rate is the thickness of this membrane. So again, your area is the same, the only thing that is changing is the thickness. So your essentially your drug release, amount of the drug released from this device depends on only on the length of the membrane thickness. So if you just take a ratio of these two values, you'll immediately get that the new thickness, which is now going to slow down your release, is should be your 25 micron. Is this clear? So when you had a 5 micron thickness, 5 mg of drug was being released. So if you want the drug release to be slow in the same given time, is ultimately you have to increase the thickness. So it usually so this is how you try modifying your device parameters depending on what kind of release rate you're looking for. Is this clear?
Yes, ma'am.
Yeah, thank you. I'll move on towards the next question if there is no doubt. Okay, so the next is a core shell type nanoparticle is synthesized. The radius of the core is 2 nanometer, whereas that of the whole particle is 5 nanometer. What is the ratio of volumes of the core to shell? So essentially the particle is like you have something inside the particle. On top of that there is a shell. We know the radius of the core. We know the radius of the whole particle. We just have to know the ratio of the volumes of core to shell. Okay, this is a pretty straightforward question because all you have to do is take the ratio of the volumes. So yeah, so you have the radius of the core, you have the radius of the particle. You just take a ratio of these two volumes. Again, it's a sphere, so the formula for sphere volume is 4 by 3 pi r cube. Just take a ratio, you'll get the answer. I hope this is clear. Nothing much of drug delivery to be discussed here. It's just simple math. Okay, I'll take the next question then. Next is we have to consider that the proteins are adsorbed on the surface of an implant using a monolayer model, meaning there's a implant. On the surface of that there is one single layer of these proteins, and according to Langmuir adsorption isotherm we get something known as a theta value. Whereas what is theta? This is the ratio of sites occupied by the molecule and total number of sites that are available for adsorption. So your implant will have a surface. It's going to be a finite surface, right? So this value is essentially going to tell us how many sites are occupied by the protein divided by how many total sites are present on that implant surface for the protein to adsorb. Then we have been given this value of K and P, which is the concentration of the molecule. And we have been told a cytokine is trapped inside a chamber at a concentration of 2 millimolar. If there are 10 power 5 total binding sites, how many of them will be occupied at steady state? And we have to assume equilibrium conditions, and we have to write the answer as a multiple of 10 power 4. So is the question clear? So we have a cytokine that is being adsorbed on the implant surface. We know a few parameters here. We know the value of K, we know the concentration of the molecule, and we also know that there are the total binding sites are 10 power 5. So your denominator we already know is 10 power 5. We just want to know how many of these sites will be occupied by our particular cytokine on the implant surface. So you already have the formula, you just have to put in the values and get at the answer. Somebody texting something? Okay, yeah, so one answer we have got is 8 into 10 power 4. So whenever you are entering the answer in the system, you just have to write 8 if that is your first answer, because the question already is asking us to answer as a multiple of 10 power 4. So I'll consider your answer as 8 here. Thank you for answering. Anybody else has a response? Or wants to give this a try? Okay, I'll discuss the answer then. Yeah, you're perfectly correct. Whoever answered, Ananya. The answer is 8. So this is just the method I've used to solve it. So you already have theta, which I said was a ratio of sites occupied on the implant surface divided by your total sites. So that's that, and we have the value of these parameters. We know what K is, we know what concentration is, which is in this case is P, and we know the total binding site. So you just put the values here. So total binding sites would be so your theta is 0.8. In that you already know, so theta is your sites occupied by your total sites. Total sites you already know is 10 power 5. We just need to know the value of this numerator here, which I am denoting by x. So if you just solve this, you'll get it as 8 into 10 power 4, and the final answer that you will be entering will be 8. Is the question clear? The question might look a little difficult when you see it, but then once you understand it, it becomes pretty easy. Is this okay? Okay, if there are no doubts here, I'll just move on towards the next question. I believe this is the last question I have for you people. So this is calculate aerodynamic diameter of a polymeric spherical particle with diameter 2 micron and density 4 gram per centimeter cube and shape factor as 1. So we have to report the answer in micrometer. So if you know the concept of aerodynamic diameter, you should be able to solve this. It has a pretty straightforward formula. Anyone? Oh, you people are already answering. Sorry, I didn't catch it. So yeah, somebody's answering it as 2. Anybody else has a response? Thank you for answering. Okay, let's look at the answer. Oh, you answered as 2, is it? Okay, actually it's 4. We'll see how it is. So your aerodynamic diameter is nothing but the actual diameter, the physical diameter of the particle divided by your density. Into your root of the density. So you already have the values here. You know the actual diameter, you know the density of the particle. So you just put it into the formula, you'll get it as 4. Is this clear? So your aerodynamic diameter is definitely going to be different, not necessary, but in this case it's different than your physical diameter because of the density. So your aerodynamic diameter is, you just have to remember this simple formula. Aerodynamic diameter is your physical diameter into root of the density. Is this clear? Do you people have any doubts in the questions that we discussed? So something similar you can expect, and make sure you're thorough with all your concepts, be it for calculation or be it for understanding the concepts of drug delivery, tissue engineering, what are all devices are there, what all methods can you do for improving the treatment or an existing treatment. Are we going to attempt all objective type questions, or there may be subject? Oh no, so the exam pattern is whatever you have seen in the assignment, this is exactly how your final exam is going to be. There won't be any subjective questions. All the questions will be your either MCQs, where you have to choose either one option or multiple options could be correct, or your numericals where you have to physically enter a numerical value. There won't be any subjective type questions. That is as far as I remember how NPTEL takes exams, but I can again confirm it with the existing TAs. But yeah, I don't think you'll have any subjective type questions. Any other problems asked? What do you mean by that? Oh, yeah. So these are all the numericals which I have from for you. I've just pulled it out from the assignments. Yeah, regarding this negative marking question, as far as I remember, there there is negative marking for questions which are MCQs. Negative marking won't be there for your first I'll stop presenting, sorry. Negative marking won't be there for your numerical type questions wherein you have to enter the questions which we saw today. Those will not carry negative markings, but your MCQs will definitely have some negative marking. So before you even start the exam, you will be so this is a computer based exam, you have to give it on a system. So before you start, the questions are displayed. You'll get some 10 minutes to read through the instructions of the exam. In that, it will clearly be mentioned. Make sure you first read that thoroughly. Some questions do carry negative marks, some won't. So you just have to be careful of what questions have negative marking before you attempt answering. Yeah, most welcome. Are there any other doubts?
Hello.
Yes, Vishwas, I can hear you.
Yes. Good evening, madam.
Yeah.
Ma'am, my question is that what is the weightage as for the 1 week, 2 week? That means total 12 assignment is there.
Yes.
What is the weightage regarding that?
Weightage, I think you have it must be mentioned on the NPTEL site, right? I don't think it's completely, I think it's 20% or so. Yeah, I'm not
Okay.
sure actually, but you can check it on the website. You'll get that information once you log into the portal. There you will have the, if you have registered for the exam, you have registered for the exam, right?
Yes.
Yeah, so in that it will be mentioned on your portal that how much weightage is being carried for the assignments. As far as I remember, it's 20%.
Okay.
You can also check it
20%
once.
per week.
No, not per week. Total 20%.
Okay.
Yeah. So
Yes,
some,
ma'am.
yeah. Okay. So, but give it a check once before you go for the examination.
Yes.
Yeah.
Thank you.
Most welcome. So somebody is asking, shall we do calculation work in pen paper, ma'am? Yeah. So when you go to the center, so you'll be asked to come to a particular center to write this exam. So therein they will give you rough papers. I don't think they'll allow you to carry anything inside, some paper or anything, but they will provide rough papers. It's safer to go with your own rough papers in case they fall short of it. But yeah, you'll be allowed to do your rough work on pen and paper, and then it's okay, it's done. But I don't think you'll be allowed to carry calcs. You won't be having calculators, that you have to do manually all the calculations. But yeah, pen and paper, definitely you can do that. Welcome. Okay, if those are the only doubts, I think we can stop the meeting here, and I would wish all the best for all of you for your final exams. Any other doubts?
Hello, madam.
Yes.
How many questions is there, madam? 75.
How many questions? I don't know. Because these numericals will not usually carry 1 mark, right? Some questions will carry 1 mark, some questions will carry 2 marks, some questions might carry 3 marks also. So what I've usually seen is the numericals usually have 3 marks. So the total number of marks would be 100. How many questions depends on the person who's setting up the question paper.
Okay.
Yeah.
It can be depends on the numerical as well as the MCQ types.
Yeah, exactly.
Yes.
So they'll just divide in between how many numericals they want to ask, how many one mark MCQs or 2 mark MCQs they want to ask. So total number of marks would be 100.
Okay. And in MCQ there is a negative marking.
Yeah. As far as I remember, there will be negative marking in the MCQs. Numericals will not carry any negative marking. So I would suggest you attempt all the numericals. Even if you think that your answer is incorrect, you just whatever you have calculated, you attempt all the numericals. So as I said, before starting the exam, you will be given some 10 minutes to read through the instructions. In that instructions also it would be mentioned that which questions are carrying negative marks and which are not. Go through that once. But as far as I remember, or as far as I know, the numericals will not carry negative marking. So you can attempt all the numericals you want. MCQs you need to be a little bit careful because yeah, the negative marking would be there. Just check it once before you start answering.
Yes. And in a numerical, there is need to put up the range, exact value, ma'am.
So yeah, some questions. So whenever the question is given to you, they will. I think numericals will have a range. So for few calculations it's like subjective, right? Some might round off the value, some will not. So in that case, if you so let's say you are getting a value something like 2.56 in for questions where your answer is something like 2.56, you will have a range. For questions where your answer is completely a round figure, like we just saw 8 into 10 power 4, right? Therein you don't expect a range because 8 is a whole value, so therein you won't be getting. But most of the numericals will have a range.
Yes, yes. Okay, okay, okay.
Yeah.
And what is the next session is?
Yeah, so this would be the last session. I
the-
think you have your exam on 23rd, is it? I don't know the date of this examination.
27th. 27th, ma'am.
Okay. So yeah, so this would be my last session. So I'll just give you my email ID in case you people have any doubts. Yeah, so Pooja, this would be the last session, but I have just posted my email ID in the chat box. If you have any questions, you can just write me a mail and I'll try clarifying it before your exams.
Yes, yes. Okay, ma'am.
Okay. Any other doubts? If not, then I'll stop the meeting here. Okay. Bye bye. All the best, all of you.
Thank you, ma'am.
Thank you.
Most welcome.